Hi guys, this is Mrs. Michek here, and today we're going to be talking about the pH scale. One thing that's really important to know about the pH scale is what exactly pH stands for. So pH stands for potential hydrogen. So when we're talking about this and we're talking about pH, that's why the P is lowercase and the H is always uppercase. It's because it's talking about potential hydrogen and specifically hydrogen ions, H plus ions in solution. So if you remember from the last video, we talked about the hydrogen ion being transferred from the acid to the base. So that's the same hydrogen ion that we're talking about right here. Potential hydrogen ions in solution. Okay, so a lot of this might be review, but just in case it's not, you need to know where certain things are located on the pH scale. For example, if a substance has between a 0 and a 7 pH, we call that substance an acid. If a substance has a pH between 7 and 14, we call that substance a base. If a substance has exactly a pH of 7, it is neutral. For example, pure water, meaning not necessarily the water that comes out of your tap or ocean water or pool water, okay, but pure water, nothing else is in it, that would have a pH of 7. Some other things that you need to know are that acids actually have more H plus ions. Okay, and really, what do they have more H plus ions then? Remember back to the Bronsted-Lowry model, they have, or actually back to the Arrhenius model, they have more H plus ions than OH. Okay, bases are the opposite. Bases are going to have less H plus ions and more OH minus ions in their solution. Okay. One last thing to note is that the pH scale is on a logarithmic scale. Meaning, if I have an acid that has a pH of 1, and I'm comparing that to an acid that has a pH of 2, since it's on a log scale, this acid that has a pH of 1 is actually 10 times stronger than the one that has a pH of 2. Same thing between the acid that has a pH of 2 and one that has a pH of 3. So an acid that has a pH of 2 is 10 times stronger than one that has a pH of 3. Well, because of that, an acid that has a pH of 1 is actually 100 times stronger than one that has a pH of 3. If we go out to an acid that has a pH of 4, an acid that has a pH of 1 would be 1,000 times stronger than a pH of 4. Also notice that where I've said the strength lies, stronger acids have a pH closer to 0. Similar in bases, stronger bases are closer to the end. And both weak acids and weak bases are closer to 7 in this area, close to neutral. So weak acids are close to 7, weak bases are close to 7 as well. And that's a little bit of information about the pH scale that you can use in the next few videos moving forward. There will be quite a few videos about doing calculations involving pH, OH, and H+ ions in order to figure out if something is an acid or a base. So make sure you watch those and have a good understanding. I hope that has been helpful.